Let's take a look now at water demand. As Jack and Jill found out, water is most appreciated when it's not there. First, let's familiarize ourselves with flow and volume. Volume is measured in cubic meters, which is the same as kiloliters, whereas flow is volume divided by time. And depending upon the timescales, which are quite long for water in respect of electricity, it can be in liters per second, but more likely kiloliters per hour or kiloliters per day. Now, meters can measure pressure and flow, but for our purposes, we just need to remember that meters measure volume. And what are we referring to with the word water demand? Well, we only need to remember that both supply and demand refer to flow. Demand is the flow required by consumers, and supply is the flow that must be delivered to meet that demand. Water demand occurs over longer time periods than electricity, and it's very seasonal. Depending upon the particular climate of an area, off-peak demand could occur during the rainy season, and peak demand could occur during the sunny, dry season. We can also influence water demand just like we can electricity. We can decrease the peak demand through higher tariffs, water restrictions and surcharges, that's penalties, in the dry season, and we can encourage things like self-storage in the rainy season with higher seasonal thresholds and subsidies, that's during periods of off-peak demand. Without proper measurement and control, things can get quite out of hand.
This is a very serious matter, and everyone in this room is under the suspicions.
Well,
What was that?
The demand for water can be influenced by the supply utility. As I've said, consumer requirements vary considerably with the season. Consumers with running water often take it for granted, a problem often exacerbated by its low cost. Consequently, there's a high degree of waste and unnecessary demand. It's also more difficult and costly to determine and prevent technical losses, which tend to happen during times of stress. The utility influences consumer behavior to change what water they use and when they use it. So once again, looking at our conveniently linked demand and supply curves, this can be represented. Now, with respect to water, normally this is stored in dams, but it is possible to find alternative to generally more expensive sources of water from aquifers and desalination. The result is that the supply curve is normally quite inflexible. Using the two graphs, we can tell when that demand will occur, that's on the right axis, and what will be the cost of production and/or price received from the left axis.